Black math! Give me some math and I'll give you some flack. Black math!
Number one, Rosa. Number one, Rosa. You can follow along with me on the screen, or if you're at home, open your test. Number one, Rosa. Number one, Rosa must design a flag that will be exactly the same size as the triangle below. Here's the triangle below. Okay? Exactly the same size as the triangle. The flag will contain a right angle. Rosa knows that she only needs to pick two other dimensions to make sure that the flag, it's also a triangular flag. So I don't know if you were confused by that. The flag will contain one right angle. Rosa knows that she only needs to pick two other dimensions to make sure that the flag is congruent to the triangle. List all pairs of dimensions Rosa could use to ensure that the flag is exactly the same size and shape as the triangle. For each pair of dimensions, write each triangle congruence theorem applies, okay? So here's what I want you to do. This is a big problem because you have to list all these things. So here's A, B, C. Okay, and so if we want A prime, B prime, C prime, or you could even say D, E, F, whatever, then you could say that the right angle is already the same. So I could use my two different things here and say, okay, I could use LL, right? LL means AB is congruent to A prime, B prime, and BC is congruent to B prime, C prime. All right, so that's using the LL theorem. What other theorems are there besides the LL?
SAS.
I know, but with the right triangle, so that's basically what LL is, SAS, right? Because we know that right angle is congruent to the other right angle. Okay, but there's like an HL, right? So we know that AC is congruent to A prime, C prime. And also you could say AB is congruent to A prime, B prime, but that's not the only L, right? You could say, use another HL and say AC is still congruent to A prime, C prime. And also BC is congruent to B prime, C prime. Okay? What else is there? What else is about it? You guys know what that's from? What else is about it? You guys ever watch Kid History? You should Google that. It's so funny. Is there any other right angle theorems?
Oh.
There's LL, there's HL.
There's HA.
Yep, so you can do an angle, right? So you can do an angle, so you have, what is it? HA. So HA would mean that AC is congruent to AC. And also angle A is congruent to angle A prime. So A prime, C prime, sorry. Angle A prime. You could also do another HA and say AC is congruent to AC, which is the hypotenuse, right? A prime, C prime. And then BC, or angle C, is congruent to angle C prime. Okay? And that's pretty much it. So there's going to be just one LL scenario because there's only two legs. But there's going to be an H, there's two HLs because there's two legs. So an H with one of the legs and H with another one of the legs. So you just have to write all that out. It's kind of a lot, but include as much as you can. If you forget these, there's only three different ones. There's this one, and this one. Sorry. Okay, so these 5 things. 1 LL scenario, 2 HL scenarios, and 2 HA scenarios. All right, number 2. Find the centroid of angle EFG, of triangle EFG. So here's what number 2 says. If I were to graph these, number 2, -5, 5 is right there. This is -5, 5. -1, 3. And then -3, 1. So here's what the triangle looks like. And I want to find the centroid. Okay, and if the centroid doesn't end up on a nice pretty point, then something's wrong. How do you find the centroid? And you, if you didn't figure this out already, please use graph paper and a straight edge. Okay, so graph the 3 points, make a triangle. Centroid is the intersection of all the medians. Remember the medians where you go to the middle of the opposite side. So if I drew that median, if I drew this median, looks like it's right there. If I drew this median, which doesn't line up very nicely, unfortunately. It looks like it's right there. Okay, so this point, what point is that? That looks like -3, 3. So use graph paper and use a straight edge. So connect the medians, the centroid, write this down. Centroid is intersection of medians. And what's a median? Well, median is vertex to midpoint of opposite side. And you can usually eye that. You'll be able to, on your graph paper, you'll be able to see where the midpoint is pretty easily on the opposite side. So take a straight edge, connect the vertex to the midpoint on the opposite side. Take the vertex, connect it to the midpoint on the opposite side. Vertex, midpoint of the opposite side. And then where they all 3 intersect, that's the centroid. Yes? Because it goes left 3, up 3. That's that dot right there. Yeah. This one is -3, 1. That's one of the points they give you. They're going to give you the 3 vertices. So you just have to find the centroid. Can you guys handle that? No? Are you stressed? Okay, so really what makes it stressful is remembering, okay, what the heck is a centroid? What the heck is a median? Okay, but if you can remember this, and you can look at this right before you take the test, and you can start with these questions that you're confused with. So plot the points. You guys know how to plot the 3 points, right? On a graph. Okay, and then you just connect each point to the midpoint of the opposite side, and they should all come to the same point. If they don't, then something went wrong, okay? But they should. You should be able to find those pretty easily. And if I can find it not on graph paper and figure it out, then you can do it on graph paper. Maybe start with that one on Tuesday, and if you need a little nudge, I can give you a little nudge in the right direction, okay? All right, number 4. Are the lines, or number 4, are these lines parallel or perpendicular or neither? Y equals 3x minus who cares? And y equals 5 plus 3x. Sorry, this is 3.
But no, this is 4.
This is 4. Sorry, let's do 4 and then do 3. That'd be fun.
Crazy.
Let's live a little. All Are these parallel, perpendicular, or neither? Parallel, perpendicular, or neither?
They're
Parallel.
Why?
That's
Yes.
next time.
Yeah, the x coordinates or coefficients are the same, right? So same slope. Remember, whatever x is being multiplied by is the slope, if you have y by itself. If you don't have y by itself, get y by itself quickly, and then look at what x is being multiplied by. Same slope means parallel. Okay, what if they're perpendicular? What do they look like? Negative reciprocals. So if one was 3 and the other one was negative 1/3, see how that's flipped upside down and it's negated. This is perpendicular, but these are the same, 3 and 3. M equals 3, M equals 3. Okay, so the test will probably have one of those options. It won't even, I think it'll either be parallel or perpendicular. So if y is not by itself, make sure you get y by itself. All right, let's do number 3.
I have a question.
Yes.
When you write EC on a test in our like grade, what's EC? Extra credit?
Yep.
So it just means it was an extra credit problem.
Yeah, I know you're not used to seeing that.
Ha ha ha.
Because you,
I have
this is
done
like,
spectacular.
I know,
mistakes,
you've done great. But you did extra credit this time. I think you did the practice test early, or you might have done some more extra credit that I offered on the test too.
I don't know. I did fine. I still don't want to take that final.
You're awesome.
Is there any more extra credit we can like do in the class, like in general?
We'll figure it out on Tuesday, because you technically don't have to. You could just bomb the final if you wanted to, because I dropped one test. So if dropping a test doesn't help you to get to an A, then you have to make that moral decision.
What if I just do
Well, you have to at least get a 50. So if you do all the problems, the lowest you can get is a 50.
Like
if I
even
just
if you
wrote
write like
A
19,
as the answer to
19
every
for all of them.
No, I would still give you less than a 50.
What if it
But-
was a 1/7?
Number 3, a circle
What if I wrote a differential?
has a
Yeah.
diameter of 16 inches. When in doubt, draw it out, okay? It's so much easier. You get a visual. What is the area? Okay, area equals pi r squared. Write that down if you don't know it. After
I
you
knew
slap
that.
your hand, because you should know this. Okay, circumference, what's circumference?
Pi squared?
Pi times
Diameter.
diameter, not squared, just pi times diameter. Area, squarea. When you're finding the area, you're going to square something. That's the radius. So we don't want the circumference, we want the area. So what's the radius? Yep, so 8 squared. So this is 64 pi. But number 3 says use 3.14 as pi. So let's do that math. Who's got that? 64 times 3.14.
I would. Is it 200.96?
Cool, so 200-ish, 200-ish, so 200.96. What is it, inches, square inches? Boom, good job. Oh, we already did 4. We're gonna do it again. Good job. Did you get that problem right in pre-algebra too?
No.
Oh, you skipped pre-algebra, didn't you?
Oh yeah.
I took pre-algebra in like 7th grade. I haven't taken pre-algebra in so long.
Okay, find the value of x in the triangle. All right, let's Pythagorean theorem this
A
stuff.
squared plus b squared equals c squared.
Okay, and unfortunately, this is not a Pythagorean triplet, so you have to give it, and it says, give your answer in simplified radical form. So get as far as you can, and if you blow the simplified radical form, you'll still get partial credit. So what's A, what's B, and what's C? First step, always do this, guys. Always write it out. So the only one that's important that you really need to match up is the C. Which one's C? 3, 6, or x? X, that's the hypotenuse. So x squared equals 3 squared plus 6 squared. Okay, so 9 plus 36 equals x squared. X squared equals 45. X equals the square root of 45. If you get this far, good job. You're right, you're just not in simplified radical form. What the heck does that mean?
Oh, that's where it's, what's the number?
Square root of 45.
So you have to take the square root out of it. So it's 3 and 15, and then out of that you can take 5 and 3.
But neither of those are squares.
Oh yeah.
So 3 and 15, that's right, but you still left with square root of 3 times the square root of 15. What else is in 45 that's a square?
5.
So 5 isn't a square.
Oh, never
5
mind.
squared is a square. 25 is a square. So 9 goes in there.
9 and 5. I knew 5 was in there somewhere.
So what should I write next?
9 and 5.
Square root of 9
And square root
and
of 5.
square root of 5. What's the square root of 9?
3.
So 3 times the square root of 5. That's it. So that means the same thing as the square root of 45. If you are confused, put that in your calculator. Type in square root of 45 in your calculator, see what you get, erase it, and then type in square root of 5 times 3, see if you get the same answer. This will tell you if you did that part right, okay? Don't be afraid of your calculator. It's not cheating. It's just checking your work. Okay, number 6. Use the given paragraph proof to write a 2-column proof. Okay, so this is going to tell you all the steps. You just have to convert it to a column proof. Some of you guys did okay with this on the last test. We had to remember that it was the flow chart proof, but you just didn't translate it correctly. So let's make sure you understand this before we move on. So number 6. So here's what the paragraph proof says. So you can look up here, and if you're at home watching this, you can look on the test. But here's what's given. So I'm going to my first statement is my given. Triangle XYZ is a right triangle. And then also angle Z is the right angle. Okay, why do you know that? Because it's given. So I'm going to draw a little picture here. This Z is the right angle of the XYZ triangle. Okay, so here's what I want to prove. I want to prove that angle X and angle Y are complementary angles. So I'm going to go down here. I don't know what number this is, but I'm going to say the last statement, angle X and angle Y are complementary. So we don't know why this is the case yet, but once we do, we can give a reason for that. But they give us the proof. So here's the deal. Triangle XYZ is a right triangle. That's given. And angle Z is right triangle. So measure of angle 9, measure of angle Z equals 90 degrees by the definition of the right angle. So measure of angle Z equals 90 degrees by, that's the reason, definition of right angle. Okay, that's what that sentence says next. All right, this is great. This is going well. By the triangle sum theorem, okay, so that's the reason for the next statement. Triangle sum theorem. Measure of angle X plus Y plus Z equals 180. So that's the statement. Right? So all I'm doing is writing this paragraph form proof into a 2-column proof. Next it says, by the subtraction property of equality. So that's the reason for number 4. So they give us, sometimes they give us the reason before they give us the statement. So by the subtraction property, prop of equality, measure of angle X plus measure of angle Y plus measure of angle Z minus measure of angle Z equals 180. So basically what we're doing is we're subtracting angle Z from both sides. So measure of angle x plus measure of angle y plus measure of angle z minus measure of angle z equals 180 minus measure of angle z. Okay, but because of the subtraction property of equality, we can do that. Okay, so then the next sentence is, what happens is those cancel. And this measure of angle z is just 90, right? So this is, you're subtracting 90 from both of them and z from both of them. So you got measure of, so you can do this measure of angle x plus measure of angle y equals 90. They kind of skipped a bunch of stuff there. So we're going to say simplify. What they also did was they used substitution, because they substituted 90 for measure of angle z. I don't like the way they do this, but you're not correcting them, you're just rewriting it as a two-column proof. Okay, therefore, angle x and angle y are complementary angles by definition. So here's the reason for number 6. Now we know the number is definition of complementary angles. So all we did was rewrite that proof that they gave us as a two-column proof. Erase this side.
So I have a question.
Uh-huh.
So in the grade book, how you like divide up the grades is like attendance is 10%, but there's nothing for that. What's
So you guys get a freebie on that because you're attending.
so do we just get like 100 on it?
Yeah, it doesn't hurt or affect your grade. So it's just I don't include it in your grade. So it's but it is part of the grade of people online. So they have to do the attendance questions and all that stuff. So it's not hurting you or helping you. Number 7. What is the included angle of EF? Oh, EF and EG. Well, it'd be nice to do that. So EF and EG, let's see. If I drew EF and EG, well, there's E, so I have to draw G some other place. So there's G. So what's the included angle?
The name of it or measure?
Yeah, the name of it.
It would just be FEG.
Yeah, so EF and EG. So basically, this E is the only thing that's repeated. So that is the vertex of this. So you can say FEG or GEF. Both answers are correct. So when in doubt, draw it out. So here's EF and here's EG. You're not going to draw another E anywhere else, right? You can draw this any way you want, and it's still going to be that angle. So I could draw F over here. I could draw G right there. But see, look, the included angle between those two sides, so this is the angle between the two sides, is still angle E. You could say angle E, right? So there's 3 answers. You could say angle FEG, GEF, or just angle E. Okay, so this is it. This is angle E, or angle FEG, or angle GEF. So it's basically whatever letter is repeated. That's the included angle. Okay, now on the test, it might go the other way. And say, okay, on like this triangle ABC, what's the included angle? Or what is the included side of angle A and angle B? Okay, included means the thing in between. So what side is in between A and B? AB. Okay, so here's angle A, here's angle B. The side in between them is AB. So it might give you that question too, okay? So when you see the words included, that's the thing that's in between the two figures. Okay. Did they oop? I think they ooped. Did I say that right?
And I hope yes.
No, I think they talked about that.
It sounded like a hydroflask, didn't it?
No, it just sounded like anything else.
That's why I said that. It sounded like a hydroflask. Flax. Hydroflask. Oh my gosh, I should make my own hydroflask and call it a hydroflask. Okay, number 8. Is this a right triangle?
Yes.
It sure does look like it, doesn't it? How do you determine if that's a right triangle? It looks like it because it's drawn like that. But how do you prove that it's a right triangle? How do you prove this is a right triangle?
Well, there's a 90-degree angle.
Well, it doesn't say that's a 90 degrees. It looks like
Well,
one.
it's kind of like I guess it's you look at it and you just know. It's you don't have to think because you see
That will not hold up in court.
I don't think there's
Sorry.
any way for us to actually.
Yeah, there is.
We don't.
Janae?
This is the 100% guess, but because 6 and 9
No, like it would have been like a 3 by 4, 3, 4, 5 triangle, but not. It's not. That wouldn't be divisible. There's one way. There's only one way to know. Yes.
Is it because 6 and 9 don't equal 11?
No, not because of that. Yeah, Tanner. Okay, yeah, if it was more than 11, then it is a legit triangle, but how do you know if it's a right triangle? So that is the triangle inequality theorem. So we know that if the two lower ones add up to more than the third one, then it's a triangle, but how do you know it's a right triangle? You're gonna hit yourself when I tell you, yeah.
They have to equal 11.
They don't have to equal 11, but you're on the right track. Come on, guys. Tori, how do you know that this is a right triangle? How can you prove that that's a right triangle? Pythagorean theorem. It's not a Pythagorean triplet, but Pythagorean theorem, if 6 squared plus 9 squared equals 11 squared, it's a right triangle. So 36 plus 121 does not, or plus 81 does not equal 121. So no, it's not a right triangle. Okay, how do you prove that something's a right triangle? Pythagorean theorem. Okay, that's not bad, right? Now that you know, you can figure it out. Hey, number 9. Decide whether each set of side lengths could form a valid triangle. Okay, so this is where Tanner was referring to. We need to know whether these can form a triangle. Does 6, 8, and 9 form a triangle? Okay, does this form a triangle? How do you know if it does?
If it's more than.
If what's more than?
If A plus B is more than C.
Okay, well, A and B have to be the two shorter sides. So if 6 and 8 are more than 9, then it is. Okay, so I'm going to say yes because 6 plus 8 is more than 9, greater than 9.
Do we have to stick with those?
No, I just want you to know that's how I got that. I'm not just guessing yes or no. What about this? No, because 3 plus 5 is not greater than 8. Okay, it equals 8. That can't be. So if you have 8 on the bottom, and then you had 3, and then you had 5, if you put them together, they would be flat on top of the 8 side, right? Okay, what about 4, 9, and 14? No, because 4 plus 9 is not greater than 14. So the two smaller sides have to be greater than the third side. Okay? Can you guys handle that? All right, that's number 9, number 10. Use the law of syllogism. Syllogism means more than one. So what's the other one? Detachment, where it's like, if it's Christmas, Mr. Flack is going to wear an ugly sweater, right? It's Christmas, Mr. Flack's going to wear an ugly sweater. But if it's Christmas and it's snowing outside, then Mr. Flack is going to wear an ugly sweater. That's syllogism when you have more than one iffy thing. Yes?
What are you supposed to be?
I'm like a decorated tree with masks as ornaments.
So if I ever need a mask, I'll just come by here.
Yeah.
Actually, is this what your ugly sweater thing is?
Yeah.
Oh, I didn't put 2 and 2 together. I thought you were just dressing
It's
up.
more like an
I
ugly
love it.
costume.
Okay.
Like I
I
love
mean, as
it.
like an ugly Christmas sweater costume, you know?
No,
Because
it's
it goes
the
like
best
on your
costume
head
here.
and it's on your.
Yeah. Yay, you're ugly. Okay.
No, I never said that. Now I feel so bad.
It's all right. It's cool. I normally wear stuff like this around the house.
Yeah,
Don't worry,
yeah.
I'm used to it. Yeah.
I like
Yeah.
your one last year.
Thank you. Okay, use the law of syllogism to write a valid set of conditional statements for the following 3 statements in the form of if P then Q, if Q then R, and if P then R. The supermarket is open. So, if the supermarket is open, all we're doing is substituting supermarket is open and for P, okay? If the supermarket is open,
I really want to go like
okay, then what's Q? Q is Mary can buy lettuce. Then Mary can buy lettuce. Okay, and then we're going to write if Q then R. So if Mary can buy lettuce, and what's R? Then Mary can make a salad. I feel like we're being a little too invasive in Mary's life. Okay, and then the last thing you're going to write, so see how we wrote 1 conditional, 2 conditional? Let's write the law of syllogism conditional, which means it's like the transitive property. If the first is true, then the last is true. So if the supermarket is open, then Mary can make a salad. All you're doing is substituting these statements in for P, Q, and R, okay? Can you guys do that? Don't skip any words. Do it word for word. Okay, can you guys do that problem? So P, it says write if P then Q. Well, it tells you what P is. The supermarket is open. And it tells you what Q is. Mary can buy lettuce. So all you're doing, instead of saying if P, you're saying if the supermarket is open. And instead of then Q, you're saying then Mary can buy lettuce. Okay? So you're writing 3 sentences. 3. Okay, number 11. Okay, the diagram shows the floor of a living room. What area of carpet will be needed to cover the floor? It kind of gives you a hint here. And because it gives you some dotted lines, so it's like you're going to cut out this section here. Oop. Okay, so it looks like 10 feet there. This is a 4 by 8, right? Is that 8? And then another 4 by 8 up here. So you could do this multiple ways, but there is an obvious, easier way to do this. 16 or 10. So unfortunately, you can't just say 10 squared plus 10 squared because these overlap. So see how I can't just add this square with this square, right? Because they overlap. But what could we do? And I like that they use carpet. This is the carpet layer method. You know what carpet guys hate? Carpet guys hate seams. They want to just try to do it all in one piece of carpet. So what they normally do is they get one big piece of carpet and they cut out what they don't want. So let's do that. What's the area of the one big piece of carpet?
So you like, are we solving this like straight up? Okay, can I just solve it? So it's what, 8, what's it, what are we doing area? Basement's height, what are the numbers? What's it, 14 by 18?
So yeah, so all I did was do the one big, oh wait, it's 14 by 18.
Yeah, so it's 14 by 18, so you know that's whatever that is, and then you also subtract the 2 little squares, 8 by 4 plus 8 times
Yeah.
4
Can I
plus 8
say
times
the
4.
answer that I have?
Uh-huh.
Is it 188 feet squared?
I'm on the
Let's see. So we're doing 232, so we're subtracting 64 total, right?
Yeah.
Because those rectangles are
So it's
64.
252. Yeah, it's 188.
252 minus 64 equals 188. Good job. Is that right? That looks
Got it right.
So this is square feet. Now, even if you wanted to do it this way, well, that is problematic. I mean, I guess it's a 10 by 10, and then you have to figure out this. But do you really know how far that is and how far that, I mean, it's just confusing. So I wouldn't recommend doing it that way.
I was gonna
Do it the
say,
carpet method.
like, that's so much work.
Yeah, don't do it that
No,
way.
I think I should do the final.
So much work.
Yep, feet squared.
Wait, I have a question about the final.
Yeah.
So, if we like would only get 50%, but what if we get the 10 points extra credit? Would be the lowest possible, like,
Possible grade would be 60.
but so would you put the 60, if you got 60 on the test and that's it into the grade book, or would it still be 50?
To determine whether you have to take it,
Yeah.
I'd probably put the 50. But
Oh,
if you're close, then I'll give it to you. Okay.
I'm close.
All right, number
I don't want to math to figure that out.
number 12. A rectangular plot of land has a length of 3.5 miles and a width of what is the area? Really? Really? That's too easy.
Just write it out. I got this. I believe in myself.
A rectangular plot of land. It's basically 3.5 miles by 1.5 miles. Is it more difficult because they're decimals? I'm confused.
Is the area or perimeter solving?
So you're finding the area. So it's just 3.5 times 1.5. What's 3.5 times 1.5?
5 seconds.
4.7.
No, I'm so close. Please just give me a moment.
Okay.
I have 5.25.
Yeah, that's right. We won't tell Tori. Don't forget, that's square miles. That is a big freaking plot of land. Okay, so far so good? On the right track? All right. Move on to 13. There's pine needles everywhere.
Wonder how those got there.
No.
Do you still do the thing where if we like turn in like problem sets, we have a big give you extra credit for them?
That's if you miss like participation points and things like that, or attendance questions or things like that. So that's what I do there. But you are desperate to not take this test.
I'm so done for the year. I turned in the last 2 problems that, well, I didn't. I had 2 A's on tests, so I did that for the last
Finish
2.
strong. Come on.
I just am done.
It's the 9th inning. You got
In
this.
softball, there's 7.
Is there 7 in softball? Oh, okay. So write the biconditional of the statement and its converse. Okay, biconditional means it's both ways. So for example, if this is the conditional, so a biconditional says, uses the word if and only if, okay? So if this is the then statement, you can say x is less than or equal to 10 if and only if x squared is less than or equal to 100. Okay, you don't care if it's true or not. It doesn't say that yet. We have to answer that later. So the converse would be x squared is less than or equal to 100 if and only if. So that's the abbreviation for if and only if, IFF. X is less than or equal to 10. Okay, so a biconditional is true both ways. So it doesn't matter how you do this, it's the same statement. Okay, so when x is less than or equal to 10, is x squared always less than or equal to 100? Okay, you always have to think about negative numbers.
What was the question?
Is negative 50, is negative 20 less than or equal to less than or equal to 10?
What's the question?
Negative 20. Is negative 20 less than or equal to positive 10?
It's awesome.
Yes, it is. All negative numbers are less than or equal to 10. So negative 20 is less than or equal to positive 10. Is negative 20 squared less than or equal to 100?
Less.
No.
No. What's
Negative 20 squared is 400, right? So 400 is not less than, so this is not true. This is false. The biconditional is false. Now, if it was just if x squared is less than or equal to 100, then x is less than or equal to 10, that's true. But the converse is not. So the biconditional means the statement and the converse have to be true. So if the statement and its converse are not true, then it's not true, okay? So if you're in this class, then you're in geometry. Is the biconditional true?
Well, no, it's not.
No.
You could be in geometry somehow.
You could be at A West geometry, right? So, but the first one, so the biconditional is not true, or the converse. Since the converse is not true, the biconditional can't be true. Okay, the biconditional means both of them are true. Okay, number 14. Explain why or why not. You could say x is, if x is negative 20, then negative 20 squared equals 400, which is not less than 100. Okay, you can just give me a counterexample. All right, just give me a counterexample. X equals negative 20, it's fine, if it was that one. Okay, so for triangle LMN, LMN, LM equals 20, MN equals 15, and LN equals 25. For EFG, EFG, EF equals 20, EG equals 15, and FG equals 25. Okay, first of all, are these triangles congruent? Yes, they are. They're just reversed, right? They're just flipped over. So now the trick is write a congruent statement. So you have to match the corresponding parts. Okay? So write the congruent statement for the triangle. So you have to say triangle LMN goes with triangle. Let's see here. If I were to flip this around, if I were to flip it, it would look like this. So FEG. So now they look the same. So write it out. Draw the triangles. It's so much easier. So now I can say the triangle LMN is congruent to FEG. Okay, and it could be MNL is equal to EGF or whatever. Doesn't matter what order, just make sure it's the corresponding parts are in the same position. Okay. So draw the triangles. Okay, number 15. I tell you, I have one more part of my ensemble to show you before you leave. Did I show you this yet?
Do you, did the lights? Is it lights?
No, it's not. But Janae knows, but she's not going to say it out loud.
Today, what is it?
She's loyal.
Is it a star
No.
or an angel on the top of the tree?
Okay, in the right triangle, CDE, angle E measures 47, and the right angle is at C. Okay, so let's see. C. CDE. Okay, so the right angle is at vertex C. Angle E measures 47 degrees. Drew this a little wrong, but that's okay. Find D. How do you find D?
We know it all has to add up.
Adds up to 180, but even it's more simple than that. These two have to add up to 90, right? Because that's 90, and 90 plus 90 is 180. So just forget about that and just make sure those are complementary angles. So 90 minus 47 is 43. That's 43 degrees. Can you handle that? See how much easier it is when you draw it out? You got to draw. Take the time to draw it out. It'll be so much easier. Okay, write the inverse of the statement. Not the converse, but the inverse. What's the inverse mean? So here's the statement. If all the measures of angles of a triangle are equal, then the triangle is equiangular. How do you say the inverse? What does inverse mean? It means you're going to negate it. You're not going to switch the order. You're just going to negate everything. If all the measures, so if all the measures of a triangle are not equal, then the triangle is not equiangular. Okay, just put a not in front of it or negate it, however, whatever it means to negate it. Is this true? Yes. Is the inverse statement true? Yes. Okay, good, good? Yep.
We can just write like the not sign.
No, just write it out. But if you were, where the squigglies come in is like this. If not P, then not Q. When you're using just shorthand like that, that's when you can do the not symbols. But when you're writing out the statements, you have to use the words. Okay, so look at number 17. That's a parallelogram. Find the value of x. Well, what do you know about opposite sides of a parallelogram? They're equal. So set those equations equal to each other. 5x minus 5 has to equal 3x plus 3. Everyone understand why you just set those equal to each other? They say you can't just do that by looking at the diagram, but the only reason you can is because they tell you it's a parallelogram. And remember, we went over the properties of a parallelogram that says the opposite sides are congruent. The opposite angles are congruent. Okay, how do we solve this equation? Tori, you want to tackle this? You got this. 5x minus 5 equals 3x plus 3.
On the same side, then you get like
Is it
got the
4?
name
No.
on the other side.
Is it 4?
Yes.
You subtract like terms. So you subtract 3 from both sides. I was
3x.
gonna do the 3.
You can do that if you wanted to, and you would have got negative 8 and then negative 2x. But so I just like getting rid of the dealing with the variables first, so then I know that.
X minus 5 equals 3, and that's pretty. It's not too bad.
Then add 5, 2x equals 8, x equals 4. Okay, is that what the question asks? Find the value of x. What if it said find the length of the sides? What if it said find the length of the sides?
It's kind of gross.
Then we would actually have to substitute.
Yeah, plug in x, so the length of the side would be 15 and 15.
People who solve this using substitution, I never could understood how, and I was like, this doesn't make sense to me. So I just did it. I kind of look at the board and I'm like, yeah, I kind of just go along with what the board says.
So when your pitcher is throwing balls and not any strikes, what happens? Do you just let her finish?
No, I go and like tell her, I'm like, oh yeah, they like take her out. Yeah, I get that.
It's so
I just
weird.
I just never understood how they solved it. I just didn't. I gotta tell her, I'm like, stop sucking. And she's like,
Because you're the one who gets to talk to her. So
yeah,
listen.
I go talk to her. I'm like, why do you keep throwing it? I'd rather like just throw it a strike, and if they hit it, oh wow. But you're drunk, dude.
Okay, so we'll do 18, 19, and 20 on Tuesday before we start the test. I do have some.
Black man, give me some math and I'll give you some flack.